myself, Professor Vivek Pongade, Assistant Professor, Department of ISC, Savitri Institute of Technology, Rajan Kunte, Bangalore. Today we're going to start with the fourth module. Just we go with some of the what is we're going to learn in the fourth module. Then we start with the concept in the fourth module. In fourth module, normalization, database design theory. So basically normalization is required to reduce the redundancy in the table. If any redundancy is there, in order to remove the redundancy, in order to minimize the redundancy from the table, we're going to use the concept of normalization. In normalization, we have many other concepts. So that by using those concepts, we're going to reduce the redundancy from the table. So introduction to normalization using functional dependency and the multi-level dependency, informal design guidelines for relation schema, functional dependency, normal forms on the primary key, second, third, voice code normal form, then fourth normal form, fifth normal form. All those concepts we're going to see in the normalization first chapter. In second chapter, we're going to see the inference rule. The equivalence and meaning will cover properties of relational decomposition, algorithm for relational database design, schema design, null dazzling tuples. Are some of the concepts we're going to see in the fourth module. So we're going to start with the informal design guidelines for relational schema. There are four informal measures of quality for relational schema design are as follows. One is semantic of the attribute, reducing the redundant information in tuple. Third, reducing the null values in tuple. Fourth, disallowing the possibility of generating suspicious tuple. Semantic of the attribute. What is the semantic of the attribute? Means while creating the table, we have to give the attribute name. We have to give the attribute for those particular entity which is having a relevant. For example, for student table, we have to give the attribute name like student ID, student name, address, phone number. We can't give them as a vehicle ID. Vehicle ID is the vehicle entity attribute. So you can't give the vehicle ID attribute to the student entity. So while designing a relation schema, so we have to give the attribute name in such a way that that attribute should be related to that entity. It should form a one meaning, right? That attribute or we're going to see in a real world meaning that should provide a proper interpretation. So semantic of relation refers to the interpretation of attribute values in the tuple. For example, here the employee having an email, SSN, birth date, address, D number. So we can easily say that the employee name is ABC, his SSN number is 123, a birth date is this, address is something Bangalore, and D number is working in the department number 2. In the same way, we are giving the attribute name. We are giving the attribute name, appropriate attribute name for the each entity. This department name is belonging to department table. D number is to department table, and D manager SSN for this department, who is the manager, and that manager's SSN number is with the attribute for the department table. When it comes to department location, D number and D location, which is the department number, in which location the department is located. All those things attribute are related to the department location. When it comes to project name, project number, project location, D number, and works on table, SSN, P number, hours. So each and every attributes whatever we are giving that are related to the department table. This is the guideline one. So design a relational schema so that it is easy to explain its meaning. Do not combine attributes from multiple entity types and relationship types into a single relation. Intuitively, if a relation schema corresponds to one entity type or relationship type, it is straightforward to interpret and explain its meaning. Otherwise, if a relation corresponding to a mixture of multiple entities and relationships, semantic ambiguities will result and the relation cannot be easily explained. As given when this guideline only get violated, if we combine the attribute of the other entity in the same entity, there we are going to violate the guideline 1. Second, redundant information in tuple and update anomalies. Redundant information means if we combine the attribute of the different table in the same table, the same value, the values what we're giving the DNAME and demechanism are repeated here. Are repeated by repeating the value in the table. What it leads to? It leads to the storage excess. their storage wastage will be there. So in order to avoid that one, we should not combine the attribute of the multiple entities. And when it comes to update anomalies, if we are trying to insert the value to the table, right, because for insert there also we're going to faces some problems. Those are insertion anomaly, deletion anomaly, and the modification anomaly. Insertion anomaly nothing but while inserting the value to the tuple. For example, while inserting the value here in the same table, if I want to insert the value of the employee, but I don't know the department number one employee is hired for a company, but that employee is not yet they are deputed for any of the department. So there we have only the information of the employee. We don't have the information of the department. So there we have to place the null. So that is the where we want to place the storage space. And if we know the department number, but we don't know the employee, for example, their new department has been started, but they don't know they not yet hired any of the employee to that new department. So we are going to give the department value, new department value, but we don't know the employee information here. But here we can place the null over in the employee table. But here in the employee table we have SSN as a primary key. The constraint is that for the SSN, if the SSN is a primary key, there we should not place a null value because primary key will not take the null value. That is the main problem we're going to face in the insertion anomaly. In the place of deletion anomaly, if we remove the deletion, if we remove this SSN number, the entire row will get deleted. The entire row will get deleted. But we need this department information, but I don't know the employee information. So if you are deleting the value, the entire row will get deleted. Along with the employee, the department information will also get deleted. When it comes to modification anomaly, if I modify the D name, this research has the administrator. Research has the administrator. Though wherever the research is there, we have to replace the name with the new name. Otherwise, inconsistency will be there in the table. These are the three main anomalies we're going to face in the guideline 2. So the guideline 2 says design the base relation schema so that no insertion, deletion, or modification anomalies are present in the relation. If any anomalies are present, note them clearly and make the program to update database will operate correctly. This is the second guideline. And the third guideline is what? Null values in tuple. If any of the attributes, if we are in a table, if we try to give the more null values, there the wastage of the space will be wasted. Waste of space will be done, right? So in order to avoid that one, while designing the database in such a manner that the attributes should have some value, there we should not place a null value. Not only the storage space is the issue. Along with that, if you want to join the two table, we're going to join with the help of attribute values. If the attribute value is null, so we can't join the two table. And if you want to perform the some aggregate functions like count, sum, min, max, average, these are the aggregate functions, operations you want to apply to the attribute. If attribute is null values, we can't apply, we can't perform the aggregate operations to the tuple which is having a null value. So in order to avoid that one, we should not place a null value in the tuples. So guideline 3 is what? As far as possible, avoid placing attribute in the base relation whose values may frequently be null. If nulls are unavoidable, make sure that they apply in exceptional cases only and do not apply to the majority of tuples in a relation. Last is the generation of subprecious tuple. Just we are going to consider these two relation. The employee project, we are going to decompose this employee project into two tables. One is the employee location and employee project one, E name and the P location, and remaining attributes we are going to give the employee project SSN, P number hours, P name and P location. If we want to join these two tables, if you want to join these two tables, we first we're going to place a value for each table. Here we are placing some values to the E name and the P location. Here values for each attribute. If you want to join these two tables, you can join with the values, attribute values of the P location and the P location in the employee project one. So here, once we join here, with join Belleri, so SSN, P number, hours, phone number, then employee name, P location. SSN phone number, our PIN location binary. If the same is going to be having with the this product, this number 4534534533. This is a binary. So what we're going to see here, the same SSN number, is going to given for the multiple person. Same SSN number is given for the multiple person. It is not possible because SSN number is a unique. Each employee is having their own SSN number. By having like this, we're going to find the capricious tuple, nothing but meaningless tuple. So two people, see, E name Smith English is having the same SSN number. It is not possible. So this asterisk symbol, wherever you see in this table, it is a capricious tuple. So it is not possible in the designing of the relation. So guideline 4 says that design relation schema so that they can be joined with equality condition on attributes that are either primary key or foreign key in a way that guarantees that no separate tuples are generated. So you need to design the guidelines in such a way that we have to measure, we have to take care of all these guidelines